Welcome to this explainer. Today, we're exploring a completely fascinating breakthrough in physical geodesy right here in Malaysia. If you've ever stared at a massive bridge or a towering skyline in Johor and wondered, how do engineers make sure it doesn't sink into the ground or get misaligned over miles of distance? Well, the secret is actually hidden in invisible spatial data. So today, we are unpacking what's known as the Johor geoid solution. Okay, let's dive into this. A big question you might have is, why isn't a simple GPS height accurate enough to build a bridge? We all use GPS on our phones, right? And it's incredibly fast at pinpointing our location. But for precision engineering and surveying, standard satellite data completely lacks the physical reality of the Earth's surface. Basically, a satellite floating way up in space doesn't actually know which way water flows down here on the ground. So we're really looking at a stark contrast between two types of measurements here. First, you've got the GNSS ellipsoid height. Think of this as the satellite's view. It's smooth, mathematical, and super fast, but it's physically inaccurate for construction. Then you've got orthometric height. That is the true water level view. Engineers literally desperately need this water level view because it's based on actual gravity, which is absolutely crucial for properly leveling ground and preventing catastrophic infrastructure disasters. It all boils down to this deceptively simple equation. H equals H minus N. It looks like basic math, but this formula is everything. H is our true physical orthometric height, and H is that fast satellite height we talked about. But that N sitting there, that is the geoid model. It's like a giant translation key. It's the missing link that essentially forces all that modern satellite data to conform to physical reality, making it genuinely useful for mapping on the ground. And that brings us to the real core of our explainer today, UTSHM's Q137 project. Led by Senior Norjiha, this was a highly focused academic research initiative backed by a really lean 20,000 ringgit Tier 1 grant. The bottom line here is just incredibly impressive. This specific project successfully built Johor's missing mathematical link. They essentially solved a massive region-wide mapping headache, and they did it brilliantly. Let's move to the methodology and see how this all builds together. To create this highly accurate geoid model, the team had to demystify some seriously complex data through 3 distinct phases. First up, they integrated multi-source gravity data, pulling from the ground, the air, and satellites. Second, they modeled it using an advanced mathematical algorithm known as LSM-SA, applying additive corrections to ensure absolute precision. And finally, they rigorously validated it against actual physical leveling data right there on the ground.
The result of all that rigorous checking and validating produced 2 major outputs. And let me be clear, these are not just maps. First, you have the Integrated Gravity Anomaly Model, which provides absolutely essential regional gravity mapping. Second is the Seamless Geoid Model in Johor, creating a continuous spatial surface for height references. When you put them together, these form the absolute foundational bedrock of physical geodesy for the entire state. It's a real game changer.
Now, what is really fascinating about this project is its sheer efficiency. 3 out of 3 research objectives were achieved. Yep, that is a 100% success rate. They delivered exactly on time, they actually spent under their already lean budget, and their findings were so mathematically sound that they were published globally, including features in the highly prestigious E3S Web of Conferences. Just phenomenal execution. And this brilliantly illustrates the real-world impact of all this research, because the ultimate vision here is the Johor Geoid Height Conversion Tool. Look, this isn't just academic theory sitting on a dusty shelf somewhere. This research is literally paving the way for an everyday digital tool that surveyors, civil engineers, and local governments can plug directly into their GIS platforms. It will allow them to convert satellite heights into physical reality instantly. Talk about hitting the nail on the head for industry needs. Which leaves us with this final question. How will this unseen mathematical model reshape Johor's future skyline? It is incredible to think that invisible gravity data is what safely anchors our most visible infrastructure. So the next time you see a new highway or huge development in Johor, remember the invisible math holding it up. Thank you for joining me for this explainer, and stay curious.